Okay, because of popular request, I have been asked to do some training on HVAC. I taught this many years ago in a school, and what we typically did, we had a 1-year program, and in that 1-year program, we had 5-week modules, and you would go to class 5 hours every day, Monday through Friday, and in that 5 weeks, you would go through all these different topics. So the first class you would be learning basics of air conditioning, the refrigeration cycle, and we would be just introducing the concepts of heat transfer and some of the tools of the trade and just a lot of the basics. And then basic electricity, we'd talk about the electricity structure of the atom, the flow of electrons, and how the basic circuit is in an air conditioning system. We'd look at some pictorial and some ladder diagrams. AC 230 was like a combination of both of these two classes, but we'd be more focused on the next stages where you're working on equipment every day in the lab and doing a lot of actual hands-on. These 3 classes were the main classes that I taught for 3 years and really locked in the fundamentals that way, so it was very good. Next class after that might be motors and controls, and you'd get into each little device that operates the air conditioning system, both residential and commercial. Um, you'd have a class on furnaces, and then a class on heat pumps, where you're just basically working on air conditionings that are heat pumps, and they're very similar to regular air conditioning. Duct design class, a refrigeration class, and then something of a wrap-up where you're working on residential and commercial equipment a lot in the lab. You might break down a system completely and rebuild it, rewire it, do a lot of field trips, these great trips where we'd go out to somebody's house who'd sign a waiver saying that if we burned down their house, it wasn't our fault, or if we're students basically. But that was fun. We went on a lot of field trips in that class. I did enjoy doing those. And then we'd also cover customer service, technical math, and career planning, and we would wrap those into little part classes, so they might be tied in there. The AC 230 class, more breakdown. These were just some of the notes that I had, that my goal at the end of the class, students would be able to do passive and active recovery, adjust charge with superheat and subcooling, do pump downs, attach and detach their gates properly with minimum venting of refrigerant, vacuum the system, conduct steam and pressure tests, demonstrate ability to calculate the superheat and subcooling in different ways, draw out the refrigeration, just hand draw the refrigeration circuit using 10 key points. I just picked 10. You could pick out 30 key points. Draw out the electrical circuit, explain evaporation and saturation. Should be able to replace Schrader valves under normal working pressures, weigh in a charge, understand liquid and vapor charging, restricting and metering in a liquid charge, take all diagnostic readings, calculate the delta T. That's nothing. Determine the properly working TXV. Get out air hose. Get the air out of your hoses, out of your gauge set, your hoses, before you charge the system. The sound that a compressor makes that's receiving liquid, what liquid charge does to a compressor. They might also, at the end of that class, be able to assist the tank when charging or recovering to help the compressor come off. Heat overload, precautions and dangers of doing it, how to determine in a system, well, that's not written correctly, how to determine if your system has refrigerant in it or not, or nitrogen. How do you know whether or not you got refrigerant or nitrogen in the system? If you're walking into a new install, determining the system tonnage, how to use the push-pull recovery method, how to read system data plates, determine locked up compressor using your meter, determine proper recovery tank for 410A, and knowing how to safely determine tank capacity, how to use electronic leak detector properly, and calibrate gauges and micron gauge, use a megameter, and change out system motors. Now that would be the goal for that one 5-week course. You would learn these things. Now if you wanted to, you could probably take each one of these subjects and see it on YouTube. There's probably somebody there talking about it. I'm not here to recreate the wheel or redo anybody's work, nor do I have time to really reproduce all of the lectures that would take a whole year to do in school. I can't even imagine how many YouTube videos that would be. Goal is to just get you started, and if you'll watch these training videos a few every night, you'll probably gain quite a bit. And what I would do is recommend starting with this fella here, Mike Ehrman. He's got a few short videos on how air conditioning works, animation, part 1 of 3. Watch all 3 of his videos. They're very short, but they're a great little animation on the refrigeration cycle. That's one of the first things you want to really get down, is how the refrigeration cycle works. In that very first class, I used to teach the refrigeration cycle, and we would go over this just every day and review and repeat and get them to draw it out. And basically, real fundamentally, you have a compressor, hot discharge gas, refrigerant gas comes out here. Here's some typical pressures and temperatures of that gas. Travels into your condenser. The condenser condenses it down, and it changes state into a liquid. When it's changing state, when it is going from vapor to liquid, it is giving off a tremendous amount of BTUs. That's heat energy. Those BTUs are being pushed out through that fan out into the open outdoors. Condenses into a solid liquid, comes along through here. This is your liquid line. You take temperatures there when you're trying to get your superheat and subcooling. There's also plenty of videos on YouTube on what superheat and subcooling are and how to get them. Very important when you're diagnosing a system. That liquid line goes up to the house, goes into the house where it hits the metering device. The metering device restricts the line. The refrigerant passes through and it flashes off about 25% into vapor, and 75% is still liquid. This is the low pressure side of the system. This is the high pressure side. When we drop the pressure, we also drop the temperature, because the pressure and the temperature are linked. The liquid here is coming through at 40 degrees. It enters the evaporator where it starts to change state again or boil off, and now it is becoming 100% vapor by the time it gets to the end. Some typical temperatures for how it's running in the evaporator: it might be at 40 degrees. When it's going through the change of state, it's absorbing a ton of BTUs, and that is how we are pulling the BTUs out of the house air, the air that is too warm. Blowing that fan across there, it's 40 degrees. It's coming out at 55 on the supply vent. Comes out here as just a cool vapor gas. Heads back to your compressor as 100% cool refrigerant gas, and it cools down the compressor too. That is the refrigeration cycle very, very quickly. Watch that over and over and over. It's a few of my favorite diagrams in this one. But if you go into the books, the many books that I have, there's just tons of great little points to talk about. All of these pictures are quick little points to discuss. They could be a quick 10 seconds, or they could turn into a full hour discussion. Just lots of good training material. And this little flash drive of pictures is just a 1/10 or 1/20th of all the material that I have. So I guess if these videos are very, very, very successful, I might be inspired to do a lot more and recreate these classes. But for right now, I just want to get you started on the refrigeration cycle. Watch Mike's little videos. They should take you through and get you to that first point, and after that we can start talking about basic electricity, and there's a few videos I can point you to, but there's also some stuff on that I'd like to upload and discuss. When you have the basics of the refrigeration cycle down and you have the basics of electricity, then we can go into more troubleshooting. And it's really funny. I've been looking for some good troubleshooting simulators on YouTube, and I found one called, I think, Interplay Learning. Really phenomenal video. It's got great graphics, colors. It has video, interactive videos that show you actually what it looks like in the field. And I went to their website to see what the thing cost, and it just says contact your sales rep. So I have a feeling that that system cost a small fortune. But the great thing is I have some simulator programs from my teaching days, and we can go ahead and work out some simulations right from my computer, and we can go through like different faults and things like that. And what I recommend is you go through a quick 4 or 5 minute simulation that I go through, and then type up that same fault for HVAC in YouTube, and there'll be some guy, guaranteed, he'll be got his camera phone and he'll be videoing exactly what he's doing, so you can get an interaction there from both the computer that I'm doing and also the person in the field who's doing it. So that's what we should do. I've got a good program for showing simulations of both the mechanical side and the electrical side. I've also got another simulator program that's just electrical troubleshooting that I think I've used it once. I'm a little fearful of opening it because back in the day when I was teaching, some nasty virus got into the computers of the school, and I've been a little afraid to open this stuff up because I'm afraid that virus is still lurking in there somewhere. But there is that other program that's just basic electricity, and then I've got another program that I've never run. I've got to go ahead and run that sometime, and it's just ladder diagrams. So that should be interesting if we ever get to that point. We'll see. When we talk about basic electricity, I'll probably start with this. And when I used to teach basic electricity, I told everybody a simple circuit, it's a loop, and this kind of shows the loop. Now this is kind of like a little backwards from the way I used to teach it. I used to teach the arrows going this direction, and I always used to say, this is your power source. This may be L1, this is L2, and I used to say L1 to switch, switch to load, load back to L2, L1 to switch, switch to load, load back to L2. And every day we'd talk about that. Now of course it will work this direction too. You could take this line, you could call this L1. You can do L1 to load, load to switch, switch back to, and then switch back to L2, or it becomes L2 on this side of the load. You can label this L1 or you can label this L1. Doesn't matter. Just remember that they change from being L1 to L2 based on the load. It's L1 on this side, it's L2 on that side, or if you're going this direction, it's L1 here and L2 there. Doesn't matter what you call it, but L1 and L2 should never meet before they go through a load. If these two touch before they go through that load, you have a direct short. The load is the key. The switch, basically just open or close. If that switch is open, none of the electrons are moving and nothing's going to come on here. That's real basic. That is basic as you can get for the electrical circuit. Now there are tons of videos on that too, but before we get into that, first you got to lock in the refrigeration cycle, then we're going to lock in basically the types of electricity there are, structure of the atom, flow of electrons, parallel versus series, the properties of volts, resistance, and amperage, power. Some great little videos on that, and just a lot of good things to go over with you. Some of the components that you'll be frequently seeing in an air conditioning system and how to check them. There's a good condenser unit diagram. So we'll get into all of that. We'll talk about this diagram and what the latent line diagram means. We'll talk about air, EIR, and pi, and what they mean and how we calculate them. Oh, that one's already completed. This is one of my favorite diagrams in basic electricity, and we used to focus on it every day. We would talk about um, how to wire it up, and if you could wire it up on paper, you could generally wire it up. We had like wooden boards with all these components too, and you could wire them up with jumper wires. Then you'd take that knowledge and go over to an actual unit and wire it up. And it's basically, this is a ladder diagram, and this is a pictorial diagram. And then there's hybrids of those. So we've got a lot to look forward to. Also going to load a bunch of simulator programs representing different faults. Those are going to be for the guys who are already familiar with HVAC. They already understand the principles, but they just want to brush up on their knowledge and see what the simulator runs different things at. But if you're just beginning, those simulator programs are going to be too much too fast. We need to go through some theory and work our way up to that. But because they are so easy to upload, I can't help but upload a few of those before I get all this other stuff done. And really the trickiest part to doing this is figuring out um, how to take you through here in a guided but a very concentrated course, because we don't have enough time to recreate 5 hours a day for the next 5 weeks or a year for that matter. We don't have that much time, and actually I don't have that much time, so I have to find a way to give you a little boost and give you the ability to get started. But once you start getting into it, you're going to want to go out and buy some tools and work with somebody on equipment, maybe your own equipment or maybe a friend in the family. You're going to want to get into it. Here's my EPA stuff, study manuals, study cards, had all kinds of little flashcards for studying for the EPA. So lots of good things, lots of material to go through. But later on we'll get into that, and we'll see how far it goes, see how many views we get. All right, that concludes this session at least.